Welcome everyone to really the final talk of LCA 2012. We're going to wrap it up with David Barr, an open source developer contributing to WebKit, Chrome and Git. He's the principal author of a tool to batch import histories from Subversion to Git. When I read that I thought, oh cool. He's a co-member in the ongoing effort to implement native support for Subversion within Git. And his previous contributions to FOSS include porting the USB portion of iBurst wireless broadband driver to Linux 2.6 and little fixes to Plupload. I have no idea what that is, but it sounds cool. David has used Linux since the single floppy distributions. So, Hardcore Warrior, please make him feel welcome.
Thank you very much. I'd just like to start by thanking both my current and previous employers for allowing me to actually work on the clock on this stuff because they felt it was important to their own business interests. Okay, so today I'm going to be talking about VCS interoperability and of course with a particular focus on Git and Subversion and what's involved with trying to make them work together as friendly buddies. Okay, so my interest in this topic all started with trying to scratch my own itch. I was working for a consulting company on a project, a proprietary project, which had 5 years of history, 22,000 commits, and the compressed archive of their history was 2.8 gig. We started off using Git SVN to do our integration work. We internally use Git for our own development because Git is awesome and we are smart. Unfortunately, we had to push to a third party who were using Subversion for their canonical repository, meaning that we then took up the burden of relaying data between the two. So initially we were using Git SVN, and it worked all right, just doing single branch tracking. But it had some problems when it came to tracking every branch, which come down to the shape of Subversion and order n squared algorithms. So at one point, in an attempt to get the complete history in and try to just do incremental updates, I mirrored the entire history of the upstream project locally, had a large memory machine at my disposal, also quite a few cores, and I ran Git SVN trying to convert that repo. It ran for 4 days, chewed quite a large amount of RAM, I won't say precisely how much, and failed at 90% completion, which was rather disappointing. And so, you know, being the intrepid person I was, I tried multiple times to see if I could get past that barrier, and there was just some pathological behavior in the repo that Git SVN choked on. So I then started looking for alternate solutions, and so I found SVN All Fast Export, which I believe came out of the KDE project's attempts to convert over to Git, which was pretty awesome. Is written using the sort of Qt base libraries, which is a bit heavier than I would have liked, but that's okay.
Actually, just for the sake of giving credit to who disorganized the thing, came out from the Qt project and then to KDE.
Oh, cool. Okay, thank you very much. Just then, Dario was informing me that in fact this tool came from the Qt project, and the KDE guys took it from there. This was quite a good tool. I liked it very much. It was nice and quite well written. It did quite well, except for the fact that there were 3 specific commits within my 22,000 commit history, which would cause it to spew garbage indefinitely, unless they were stepped over. Which once again meant this time I could actually get a result. It was just incomplete. But it was pretty quick, which is nice. So then I used svn to git.py, and it was correct. It was correct. So it would have given me a complete history somewhere around about the heat depth of the universe. It very, very quickly went through the first half of the project history and then just rapidly slowed down until it was basically doing nothing. And so the problem was, with existing tools at the time, complete and timely conversion was simply impossible. And I guess as another bit of background, Git SVN, monolithic Perl implementation, very difficult to understand and dive into, and the problems with it are sort of deep inside its conceptual core. SVN fast export, quite good code, would have been happy to hack on, but there was a design problem, and I'll come to that. SVN to Git actually had the right design, but a very terrible implementation. So for the next step, I lifted the design from SVN to Git and tried to make it as fast as SVN or fast export. Okay, so before getting too heavily invested into the solution, I thought it might be a good thing to see if it was just me or if other people out there on the interwebs had the same problems and if they'd actually found any solutions. So I reached out to the Git mailing list because I figured if anyone's going to try converting Subversion projects to Git, it's people who use it. And I did actually come with a proposal in hand for a solution and a prototype and some stats. And so this was quite well received. There were a handful of people who had actual anecdotes of repos that would not convert with existing tools, which was useful to know. And the numbers were kind of crazy and got people excited. So I saved the world in 30 days because I'm such an awesome coder. No. So why was it so hard? Basically, there are some problems trying to map Subversion history onto Git. First one of which is that the actual tree structure is not one-to-one due to the existence of empty directories within Subversion. The second of which is Subversion uses a particularly funky way of describing file permissions instead of the usual Unix-style bit mask that Git uses, and similarly a funky representation for symlinks. And of course, it has file metadata, which currently in Git, there is no concept of file metadata. And of course, the commit metadata is completely different again as well. So the proposal I brought forward was to create a translator where I tried to slice the problem across some nice boundaries. So the idea was to write a tool that would read the Subversion dump format in and write the git fast import stream format out in a nice streaming kind of way, very Unixy. To do this, thanks to all that mismatch, it needed to also have an internal data structure to map the differences between histories so that it could do an online translation. And of course, needed to make that structure scale linearly with the Subversion history. That was a very fun exercise, and I was sort of leapfrogging on the shoulders of giants for that. And so I used some existing stuff. There was a Treep library that was BSD licensed that I used and as the basis for my data structures. And there was also, I initially used the Subversion to CC, SVN to CC project as a basis for writing my dump file parser, although none of that code actually survived my rewriting. But it did serve as an example of how you might go about writing one. And important to note, just so that people don't get confused later on, that I started this project independent of both Subversion and Git with the intent that if I did so, it was probable that it would be useful for people other than Subversion at Git at some point in the future. And at that time, it was called SVN dump fast export. It still is, but it was later on merged into the Git core under the name SVNFE. Okay, so why did it take so long? To their credit, the Subversion developers have actually produced some documentation of the protocols that they use. Unfortunately, it uses phrases such as uses only timeless FS concepts, which, if qualified by as understood by developers of Subversion, would be correct. Several of the verbs used do not mean what you think they would mean. Delete means what you think it would mean. That was good, that was handy. Unfortunately, add, change, and replace have very unusual semantics, in particularly when combined with the copy from directive that's part of the Subversion format. And so it took me, and with a bit of help from a few other people, 3 months to basically reverse engineer the meaning of these verbs by taking large amounts of real-world data and just importing it and trying to track where things diverged and then update the logic until we had a solid model. So sort of like an AI exercise or machine learning exercise. human guided. Yeah, so pro tip, if you're designing protocols in the future, try to make it so you don't require machine learning to understand them. Okay, so now that we've got this nice little module, reads Subversion dump in, writes fast import out, we need to get data in and process the data that comes out. So it turns out that it is extremely difficult to extract complete history from a Subversion server. In fact, it's even hard just to extract it from a mirror of a Subversion server. It's an extremely I/O intense process. So, for example, SVN sync is standard part of the SVN toolkit. It unfortunately doesn't work very well for projects with long history because the first step it does in the synchronization process is read the entire history metadata for the project. And when you've got a project the size of ASF, so it was about 950,000 commits at the time I started this project, that's a very high probability of failure at any point along that chain. And so basically with ASF, SVN sync will just simply fail always. So that wasn't very useful. But if you have a small project, it works well enough, and you can use that in SVN admin dump and get your history out that way. It's nice. So I use SVK, which is now deprecated, which is a set of Perl libraries and CLIs that wrap around Subversion, the Subversion APIs, and provide some high-level functionalities to Subversion. So it has a tool for doing sync, and it is actually incremental. So it provided some hope. You could actually use it to extract history in an incremental fashion. And also provides a tool which then does a dump, which would be the same as what you would have gotten from the usual tools. But yeah, these are both sort of suboptimal solutions. So as a part of the 2010 Summer of Code project for Git, the aim was to build native support for Subversion within Git. And the main outcome of that particular project was that Ramkumar Ramachandra ended up writing a tool for Subversion, which initially started as an out-of-tree patch, just to create a tool using the APIs. And later on, as he began communicating with the Subversion community, actually he garnered enough interest that they made it a first-class tool. I'll come to that. So, SVNR dump is now a first-class tool in Subversion. It's in the 1.7 release, which isn't really released yet, but it will be one day. And it provides a really, really useful general-purpose tool for Subversion. It allows you to do any kind of Unix-style interaction with Subversion using the dump format as a standard protocol. And so it has two main features. The obvious one is that it can read a Subversion repo, exercise the protocol machinery, and write out a nice dump format. And it can also do some crazies and read in a dump format and exercise the machinery to reconstruct history on a remote server, which is also extremely cool. So yeah, that's pretty amazing. And I believe there was some pushback on this because it did actually create some competing functionality with an existing project called SVN Muck. But because the problem space was substantially reduced, it actually, even though SVN Muck had existed for a long time within the project, it was able to get in straight away because it had divided up the problem quite well, and the extra complexity could be pushed on to other tools in the chain. Okay, so fast import, what issues did it present? When I first started the project, my sort of 1.0 goal was to achieve a module that would do this translation without requiring any modification to either Subversion or Git. And so we achieved that fairly quickly in the first 3 months. But then what we wanted was the ability to actually support direct application of Subversion binary deltas so that we could do sort of efficient sort of across the wire transfer. And there were sort of two ways proposed. The first one was pretty appalling, and I'm glad we didn't go with it, which was to actually add support for the Subversion binary delta format to fast import. It turns out there's some good reasons not to do this. Then the second solution, of course, was simply to add the ability to read data back to the fast import protocol, and therefore be able to apply deltas out of process and have a nice sort of separation of concerns there. So that's what we did. So we added the cat blob feature to the protocol. And similarly, to address the issue of having to track all of the metadata, sort of project history structure within the translator process, we also introduced the ls feature, which allowed you to inspect the state of the active commit as you built it. So you could execute commands, adding and removing files, renaming, applying deltas, and so on. At any point during that sequence of commands, you could inspect the current state. And so therefore, you could use that information to drive future commands without having to track the cumulative state within your own process. So that's also very, very useful in a very general purpose translation sense. And of course, all this meant that complexity could be removed from the translator. So after having these two protocol extensions, we were able to go on sort of a code hacking spree, sort of machete style, and reduce the total code size by about 40%, which was nice. Okay, so in 2011, there was another Summer of Code project. This time, I was co-mentoring together with Jonathan Nieder, and we had a great student, and basically the idea was just to pick up the ball and continue. We have a high-level architecture of how we want to implement native support, and there's several Summer of Code projects worth of work in there. And so we pointed him at the next steps that needed to be done, and away he went. So first thing he did was hack the front end of the translator so that all of the inbuilt assumptions were removed and made as configuration options. Good work. He then used that to write a simple Python wrapper around the tool that would do the various setup required to use the git remote helper APIs. And then, as part of this, he did a whole lot of testing, and he found numerous very scary bugs in git fast import. Not only found them, but actually fixed them, and also updated the documentation that didn't cover the behavior that caused these bugs. So he did some excellent code maintenance work, you might say, but it was very important. And the one thing he did that I would have just passed him for not having done anything else was he uploaded a simple patch, which, in spite of Jonathan and I having spent 2 years looking at the code and looking at the fast import code and sort of examining performance hotspots, he saw what in hindsight seemed like a very obvious optimization, which is that because we were using cat blob to read back data to apply the subversion binary deltas, the cat blob command acts as an extremely strong signal for what might be a good base for deltification for Git. And all he did was add that into the list of things to check. And so that single change improved import performance on the fast import side between 3 and 10 times for various project shapes. So yeah, that was humbling for us. And of course, we gave Dimitri the respect he deserved. Yeah, so in the meantime, there was a lot of work going on by Sever Rabelia and Jeff King, also known as PEF, to clean up the infrastructure required for native support for other protocols. And so they were doing a lot of stuff around just tightening up the remote helper API and related things. And one of the things that helped push that effort along was Jeremy came along with a sample implementation of Git Remote MediaWiki, which is just a simple Python script which would talk to the MediaWiki web RESTful APIs and basically translate the wiki history into a Git-friendly shape. So you could just check out the wiki and commit and push to it, which is pretty cool. And so yeah, so his work there actually helped find a whole bunch of edge cases in the protocol that were necessary to address to support a wide range of applications. Yeah, so there's a whole lot of future work to go, more or less reading off this one. So there's basically the majority of the Summer of Code work is still not merged in mainline, so there's work to do with that. once the work has been merged, I would like to actually upstream. There's been a lot of busy work going on inside the Git fork of the project. I'd like to actually upstream that to the parent project so that it can be made available for other projects. And so alongside that, I need to get in contact with the Mercurial and Bazaar communities to get so we can ratify the protocol extensions and have those supported in those tools. Implementations of fast import. And similarly, we need write support for Subversion that's not yet done. It's a to-do. And finally, having done all those things, we can actually have Subversion support native for Mercurial and Bazaar. I guess they'd like that too. Okay. All right, so with regard to merging the patches, there's currently at least, last count, I think there were 95. ESR had a quick chat with me about a month ago and asking where the project was up to, and so I counted, and it was 90 patches. That's not including mergers. There's a very, very tangled history. So my first sort of outstanding task is to actually prioritize the work that's already been done and try to reorder the patches so that the high priority patches come first, and then sort of campaign for support within the Git community to get those merged in. Yeah, that's hard. I have written some nice tools for doing this. Apparently, sort of letting your branch run for 6 months to 2 years and having all sorts of topic branches along the way and merging all those together does make it very hard to actually prioritize work for getting merged. So I have some tools for doing what I like to call auto magic rebasing, which allow me to specify the shape that I want the history to be in, and it tries its hardest to do that as automatically as it can and sort of allow me to help it out along the way. That's also outstanding work for me, is to get that merged in as a base feature for Git. Yeah, so I will generally have, my current plan is to make that a prerequisite for upstreaming. It would be kind of silly to upstream one shaped history and have another shaped history merged in. That would just make it very, very hard to track the work that's going on. So that's still very much a to-do, depending on the other work. This is unfortunate because ESR actually did want to use the tool to interface with his repo surgeon tool, and I had to sort of make the sad confession that it's not ready for him yet. We'll see. Similarly, there's a fair bit of work involved in actually implementing the protocol extensions. It turns out it's actually quite hard to implement fast import, at least in a performant way. And you need to be very careful about how you do it, otherwise you end up with nasty bugs like the ones that Dimitri found. So in terms of getting that implemented for Mercurial and Bazaar, I probably need to get much more closely involved with those communities to sort of have some sort of transfer of knowledge in terms of implementation. And so RAM has done some work on the reverse translation process, which is reading Git history and translating that to the Subversion format. He had a prototype, but once again, we still need a bit more infrastructure on the Git side before we can do that effectively, because Subversion is just full of crazy corner cases. And so we need the ability to track those. So yeah, there is a prototype, but it sort of only handles some subset of history shapes. Another point to note is that with the actual architecture of Subversion, doing the reverse process is actually a hard problem, because just the way that Subversion understands commits is that even though it's not advertised, every commit that you make to a Subversion repo is actually an implicit rebase. And so you can't, essentially, by design, you cannot do the Git style workflow. At every point that you push, you need to actually read back again from the server to find out what the canonical history is. And in fact, what you get back from the server is almost certainly doesn't match what you sent, which is unfortunate, but that's the model that they went with. Yeah, so of course, once again, having done all that work, there would then be a much smaller exercise to actually integrate the tool with Mercurial and Bazaar. Bazaar, I'm not so sure. I do have contact with some Mercurial developers, and my understanding is that their code base is actually quite clean and modular. And so I think that the integration wouldn't be too hard. They have some very good stuff in there about actually abstracting away persistence issues. Bazaar, I'm not so sure. Okay. So, sorry, it's a bit quick. I'm hoping you got some good questions for me.
Anyone got any good questions for me? You can hear me?
Hello. So this is a very strange question. Now, your talk is about integrating existing systems with Git, but as we had also the chance to talk privately, is there a way for, or are you thinking about a way for making Git easy to port to other systems? So the other way around?
Yes, I think this is actually a largely solved problem, and this is essentially why the fast import format exists. It's a high-level way of describing history, so it's not directly tied to the Git tag. So some concepts remain, as in the, unique names for trees and commits and that sort of thing, but the actual structure of those names is not defined, and so there's some flexibility there. And once again, it does follow the same sort of principle as the Subversion dump format, in that it uses file system operations that are timeless concepts, except that the behavior is precisely documented. Which is, there's protocol people in the Git community. Yeah.
So our question and answer time's twice as long as usual, so there's plenty of time for questions. So if you have an inkling, please feel free to speak up. Yes, sir.
Have you had any contact with anyone in the Apache Software Foundation? Subversion's all they use. I'd love to have access in other ways.
Actually, did I miss a slide? Because at some point I should have said that, no, I didn't miss a slide, I just forgot a point. In particular about getting data out of Subversion. Okay. Yes, so there's this line here that I forgot to expand on, which is that for large repositories, say KDE or ASF, which, by the way, make great data sets. I really enjoyed having access to them. You really should ask for a compressed dump. And so in the ASF case, this is what I did. I approached the admin mailing list for Apache, explained what I was doing, what I was hoping to achieve, so I got some context, and just asked, could I have, if it's not too much trouble in any kind of way, a complete archive of the history of the project. And they replied back very quickly and said, sure, it's here, we're already hosting it. Go for your life. So that wasn't that easy. It was like a 10 gig binary file to download, but internet's a lot better than out in Australia than it used to be. Yeah, for some of us. And then similarly for KDE, I eventually, once I got things working with the ASF repo and I needed yet another even larger repo, I hit up the KDE guys because they've got one of the largest repos that's open that I know about. And for sort of historical reasons to do with design decisions within Subversion, they actually serve up their history via rsync to the raw persistence format of the Subversion server. So that worked okay for me. Once again, I just was lucky to be on a sort of very low latency, high bandwidth connection. And so I was actually able to do that overnight, which is pretty nuts. And just a shout out to the ACCC. Thank you for pushing Optus to change their plans to open up their network to other providers. That literally happened days before I did this. And that was the difference between, I would have gone twice over my download quota and been shaped to sort of internet hell. But thanks to the work of the ACCC, a couple of days earlier, my cap got expanded by about 30 times. And so, yeah, so I was able to actually download the entire KDE history overnight.
Sorry, just to clarify here, when you talk about When you're talking about the ASF repo, that's every single Apache project that lived in that?
Yeah, that's every single Apache project ever, their complete history. So it's about, what is it, 12 years or something? Yeah, about 10 years-ish history. So yeah, you know, twice the length of my other project, and sort of the similar like Subversion repositories, well, just code in general tends to grow at a sort of order n cubed kind of rate, particularly when you're tracking history. Yeah, so the Apache repo was about 10 gig. The KDE repo was about 64 gig on disk, about around, and it's a bit more now. It grows very fast. At the time that I downloaded it, it was 1 million commits. A couple of months later, it was 1.2 million. So, damn. Yeah, so that took a bit longer. And then, of course, so it took me, so here's an important note I was saying about performance, right? I archived, I copied the persistent store from KDE overnight, and it took me 2 weeks to then convert that into a dump file, because it's an extremely I/O-intensive process. That was unfortunate. Of course, then once I had the dump file, I could just run experiments over and over and over, which was great. And one thing to mention there, speed is a feature. This project wouldn't have been as successful as it was if, when I started, I was paranoid about speed. I wasn't as paranoid about speed as I was. Because the tool was always very fast from the start, doing these test runs of very large data sets was actually possible, and that helped us find bugs really quickly. Another note on that is what I found with that whole process is this very consistent pattern that every time we increased the sample data by an order of 10, we would find another bug. And so that was quite interesting as well.
Just note, if I hand you the microphone, if you can just speak over it like this, you don't have to eat it, especially after last night's dinner, and it probably smells of wine and beer. So
do you think it's important or likely for Git to add support for arbitrary metadata in order for other VCSs to interoperate with it?
Yes, I do.
Do you think it's likely?
It's controversial, but it is. I attended Get Together last year, and it has been widely acknowledged as an issue. And sort of like the kernel community, we consider once there are sort of widely used implementations out of tree that we ought to bring them in line and take some ownership of that. So yeah, there are proposals up for how to handle that. The problem there to some degree is, once again, it's the mapping problem. So working out what is the representation that we should choose for arbitrary file metadata that most flexibly allows us to support a wide variety of different metadata schemes. So that will take some thoughtful consideration.
we had a question up the front here.
So kind of a more specific version of that question about metadata. According to the last round of Git surveys, empty directories are one of the most popular demanded features, and yet I'm not seeing any attempt to implement those at all.
That's not entirely the case, and it's the same problem again. It's that we actually need to think carefully about how we implement it in order not to sort of, slit our own throats and create problems for future performance. So we want to sort of, once again, expand the set of possibilities, but without also, by doing so, limit others.
What's the specific concern there?
Empty directories are not scalable. The basic problem is that, I'm trying to remember exactly, but basically it creates a sort of a large amount of noise in the sort of history signal. So I and probably most Git developers are actually in favor of coming up with a scheme to actually record empty directories out of band. There are some other reasons too, like actual performance implications. Like once you allow empty directories, this actually affects a whole bunch of pruning decisions when it comes to walking a checkout. So that actually has real world performance implications for the client. So we do want to be very careful about how we do that. It may be a cargo cult thing, but I think there is some reality to it, so we should look at it closer.
Just a shout out to anybody who's never asked a question at LCA 2012. You've got about 5 minutes left. Anybody on this side of the aisle? Come on, anything you've wanted to know about Git? I'm sure you're experts over here. He's not even squirming. This is once in a lifetime chance.
If you were developing in parallel in Git and Subversion on a project, which paradigm for branching would you tend to go toward? Because people branch much more frequently in Git.
All right, that's what I would say. That's not a paradigm, but rather a behavior. Yeah, so that sort of invalidates what my first comment was going to be, which is simply, as discussed last night or the other night with Dario, Subversion doesn't actually support branching.
You make folders and call them branches.
That's right. It allows you to duplicate things inside a large namespace. Yeah, anyway. Yeah, so in terms of that, what I would recommend, if you're doing it in parallel, in particular, if you actually want to keep the development in sync, you've got some hard choices ahead of you. It depends very much on how much shared oversight there is between the Git and Subversion users in that community. If the Subversion users are the ones with the power, then essentially I'd have to recommend using a very simple Subversion style branching strategy and encourage Git users to do what they do, be distributed, make branches, distribute them, whatever, but consider that work as not canonical. And that's where you're stuck in that situation. Yeah.
Okay, question up the front from our previous speaker.
So, given that we are rambling here, I mean, talking about different topics. So, what do you think of a versioning control system, which is a different paradigm? Because in some ways, the reason why SVN to Git was hard, I mean, we discussed that, was that the branching feature in Subversion was basically bogus. It doesn't exist at all. So, if in the future, close or remote, there will be a different system of handling, how do you see that coming? How do you think, by learning from our previous mistakes, we can migrate?
Yeah, one project I see that sort of shows some promise. It has some objectives that sort of align with problems that I've faced trying to do sort of properly distributed programming on sort of with some degree of coordination in a project is Fossil SCM, which basically aims to create a sort of, which was created with the librarian sort of mindset. So the idea is to create a sort of stable archival format for the history of a project, which is complete. Actually includes like source code, documentation, bug tracking, all the things that define a project together in one place, and everything done in a distributed fashion. I like it very much. It's a very noble objective, and so I actually quite like their high-level aim. In terms of implementation, they made some very unfortunate decisions, and I'm not sure how to go about sort of starting that dialogue. Yeah.
Any final questions? Okay, well, that was an awesome talk from LCA. I'd like to say, enjoy your golden penguin.
All right, thank you very much.
Thanks very much.
Just before I go, I'd just like to say that if you want to get involved or learn more, then you can just email me, $0.01@google.com. And if you want to widen your audience, consider CCing the Git mailing list as well. And just a quick shout out to Dylan Beattie, who made this wonderful, funky Git logo that I use on the front page. So, thanks.
Cool. Thank David one more time.